This is a very, very quick review on just essentially how to classify, not really solve anything, but how you can identify and classify the different types. So for parabolas, there's four different things to think about. When you have in an equation y to the first power is equal to x to the second power, you have, and it's a positive x squared, you have an upward facing parabola. So if y is equal to, say, 2x squared minus 3x plus 12, that's an upward facing parabola. If y to the first is equal to negative x squared, a downward facing. What some of you haven't had to deal with yet is when x is to the first power and it is equal to y squared. Well, if y is to the first power, notice the parabola is facing towards, opening is up towards the y-axis. So when x is to the first power, you got it. The parabola will be facing towards the x-axis. Whatever one is to the first power, the parabola will be facing to the x-axis. And this is in the positive direction. When y is a negative y squared, this will be facing in the negative direction. Okay, that's parabolas. Circles. Circles are probably the easiest ones. There's an x squared plus y squared equals r squared. It's a takeoff on Pythagorean theorem, or where Pythagorean theorem probably started from. What you need to know, circles are a specific type of ellipse. The coefficients to the x and the y are the same. That's how you know the difference between a circle and ellipse, at least one of the ways. When those two things are the same, you can assume that this over here is r squared. Take the square root of that to figure out what the radius is. So, and if it is just x squared plus y squared, the center will be at 0, 0. If the equation looks like this, where there's stuff in parentheses with both the x and the y, you know it's a circle is if, again, these coefficients are the same, and then the opposite of this value, that's where the new center will be. So let's see if and you have to remember that coefficients x and y are the same. All right, for an ellipse, notice you still have an x squared plus a y squared, and if there's no parentheses, we know that the center of the ellipse is at 0, 0. But what makes an ellipse different from a fully round ellipse is when the value under x and the value under y are different. That's how you know it'll either be a horizontal or a vertical ellipse. And this is how you know when that's the case. So if you take the square root of this, if the a is larger than the square root of b squared, then it's a horizontal. If the b value, when you take the square root, is larger than the a, then it is a vertical ellipse. And again, there's a plus sign between the x squared and y squared, and if there's parentheses, not use that, that's a bad highlighter. That just means that the center will not be at the origin. You take the opposite of those two values. And then finally, the hyperbola, when you have an x squared subtract a y squared, and there will be an a squared over a b squared, and that will equal 1. When it is x squared subtract a y squared, the hyperbola will be facing, the opening will be towards the x-axis. When the hyperbola is y squared minus then you know that when the y is positive, the hyperbola will be facing up and down towards the y-axis. All right, so hopefully, there we go. So here we have an x squared subtract a y squared. There's other things you're going to have to do. There's a lot to know about conic sections. For this exercise, for this video, I just want you to be able to identify or classify what type of conic. When it's an x squared subtract a y squared, and typically you'll have the other side equal to 1. The a and the b can be the same. For hyperbolas, it doesn't, notice I didn't put those in different colors. You know it's a hyperbola when there's a subtract sign and when both of these are squared. All right, that's it.